For the square, we found a board next to our football field. The length of the square is 91 cm long. And for the perimeter, we use 91 times 4 to get 364 centimeters long. That is the perimeter of the square. And for the area, we use 91 times 91. The area of the square is 8,281 square centimeters. We found a rectangle commercial board next to our football field. The four angles of the rectangle is 90 degrees by using these rulers. And then we measure the length and the width of the rectangle. The length of the rectangle is 150 cm and the width of the rectangle is 91 cm long. And so that we get the perimeter of the rectangle is 483 cm long. And then we just simply use 150 cm times 91 to get the area of the rectangle. And the area of the rectangle is 13,650 square centimeters.
We use my eyes for the circle. For the perimeter, it will only be pi because my eyeball is only 1 centimeter long. And the area of my eyeball is 0.25 pi.
This is the right triangle we found. The side length of this right triangle is 58 centimeters, 55 centimeters, and 17 centimeters. And then we just add them all together to get the perimeter of this right triangle. It is 130 centimeters long. And for the area of this right triangle, we just used 55 times 17. And the result we got is 467.5 square centimeters. This is the isosceles triangle we found. The side lengths of this isosceles triangle are 37 and 52. And the perimeter of this isosceles triangle is 126. To get the area of the isosceles triangle, first we have to get the height. The height of an isosceles triangle is bisecting this angle and its opposite sides, and it will also forms a right angle. And then we can just simply use the Pythagorean theorem to calculate the height of this isosceles triangle. And then we got the area. The area of this isosceles triangle is 565 square centimeters. This is the Stadian triangle we found. The side length of this triangle is 133, 87, and 97 centimeters. The perimeter of this triangle is 317 centimeters, and the area of this triangle is 4,219 square centimeters.
The equilateral triangle has 84 centimeters on each of its sides. Its perimeter is 252 centimeters long. Its area is 1,764 square root of 3 square centimeter.
Two lines cut by a transversal. If the alternate interior angles are congruent to each other, then that means these two lines are parallel. And this is the parallel lines we found. If two lines intersect and one of the angles they form is 90 degrees, then that means these two lines are perpendicular to each other. As you can see, we also use this triangle ruler to measure the degrees of this angle, and it is 90 degrees.
For parallel lines and corresponding angles, we use the shadows according to corresponding angles postulate. Corresponding angles must be congruent, so we measured it. It's all 150 degrees. For congruent angles, we use the football field. As we all know, it's a rectangle, so the angles must all be 90 degrees. And by right angles congruency theorem, the four angles are congruent.
We found the parallel lines and alternate exterior angles at our parking lot. As you can see, these two angles are 90 degrees. They sum up to 180 degrees. According to same-sided interior angle theorem, we can prove that these two lines are congruent, so that these two angles are a pair of alternate exterior angles. We found the alternate interior angles on the gym door. We also use same-sided interior angle theorem to prove that these two lines are parallel, so that these two angles are a pair of alternate interior angles. This is a pair of same-side interior angles we found on the vending machine. If two lines are cut by a transversal and the same-side interior angle summed up to 180 degrees, then that means these two lines are parallel. The angle measurement of these two angles are 90 degrees. They sum up to 180 degrees, so we can prove that these two lines are parallel. This is the proof. We found these two right triangles, and then we measured each side of these two right triangles. And then we used side-side-side triangle congruent postulate to prove that these two right triangles are congruent. We measure the side length of this football field. The football field is 100 yards long and 50 yards wide. And then we use Pythagorean theorem to calculate the diagonal of the football field. It is 112 yards long. This is another right triangle we found. We measured two of its sides. The shorter leg is 60 centimeters long, and the longer leg is 180 centimeters long. And then we just use the Pythagorean theorem to estimate the hypotenuse leg of this right triangle. It is about 189.7 centimeters long.